Hello, today we're going to talk about states of matter. Alright, there are 4 states of matter that we're going to talk about, or there's only 4. The first one is plasma. Alright, plasma is the most common form in universe. There we go. Matter in a high energy state in which electrons are separated from their nuclei is what plasma is. I'll say it again. Matter in high energy state in which electrons are separated from their nuclei. An example of this would be neon signs. Alright, the next one we're going to talk about is gas. Alright? In gas, all of your molecules are kind of spread out and moving around. All right, this causes them to have I'm going to say indefinite shape and indefinite volume. This is also called fixed and unfixed, whatever you want to say. So this would be unfixed shape. So what that actually means by saying indefinite shape and indefinite volume is for the shape, a gas takes the shape of whatever container it's in. So you put gas in a can or a small can or a bigger can, and that's the problem, or that's where you have your indefinite volume. So you can actually press down gas that's in something. All right, it doesn't have it doesn't have a fixed volume. It can change. Same thing with its shape. It can change. So gas is moving around. So between these, between solid, liquid, and gas, when you are changing from solid to liquid to gas, you are changing the amount of energy. All right, not heat, energy. So from go to a gas to a liquid, I am losing energy here. So when I'm going this way, I'm losing energy. When I go this way, it's gaining energy. If you saw me looking at my book down here, that's because I couldn't remember if it was in this section or the next section, whether it was there or not. So a liquid. Liquid molecules or particles, whatever you want to call it, are closer together. And they have an indefinite shape because when you pour water into something, what happens? Does it stay the same shape? No, you can take water from a pitcher and pour it into a cup. It doesn't stay the same shape of the pitcher. When you pour water on the ground, it doesn't stay in that shape. All right, so the shape changes depending on whatever device is put in. But it does have a fixed volume. The volume doesn't change. All right, so if I have 20 milliliters of water in a cup, I pour that cup onto the cement, it's still 20 milliliters of water, or if I pour it into a larger container, it's still the same volume, it just takes the shape of whatever it's in. Gas has no definite shape, so it takes whatever it's in, and the volume can be changed. All right, now our last one. So if we're going from a liquid to a solid, we're losing energy. But if we're going from a solid to a liquid, we're gaining energy. And what that means, the gaining and losing of energy, is there's an intermolecular bonding between all these molecules or particles, whatever you want to call it. So as you gain energy, those bonds become weaker and weaker. So over here, the solid has the least amount of energy, or so the bonds are tighter, the intermolecular bonds are tighter. As you give energy, they start moving more, they start hitting each other, they start moving apart. And once you've gained enough energy, they become gas. So you're actually adding energy, not heat to it. All right? And our last one over here, solid. Solid are tightly put together. They have a strong intermolecular bond between them, keeping them together. And they have a fixed shape and a fixed volume. All right? So their shape, if I take, I have a cup here that my son colored for me. I have a marker, it's a solid. If I switch containers from inside the building to in the cup, it's still a marker. Or I have it in the cup and I take it out. Did it change at all? No, the shape's not going to change based on where I put it, unless I add or lose more energy, unless I gain energy. All right, it has the same volume. The volume's not changing of it. All right, so the big example you always have is solid is ice, liquid is water, and gas is your steam that comes off. All right, so now I talked about losing and gaining energy, losing and gaining energy. There's actually names for these. All right, when I lose energy between a liquid and a solid, that is called freezing, or a freezing point. All right? When I go from a solid to a liquid, that is called melting, or melting point. Right? What's unique about these is the freezing point and the melting point are exactly the same thing. They're just going in opposite directions. So freezing is from liquid to solid, melting is from solid to liquid. All right? They're the same degree at what it happens in a given substance. All right? So if you're losing energy, you're going to freeze, but if you start gaining energy, you'll start melting again. All right? Now we come over here. We go from gas to a liquid. When I go from gas to a liquid, that is condensation. All right? That's what you have on the outside of your cup. So what's happening, or your ice, water, or whatever you have. So what that is the gas is, it always goes hot to cold. So the gas around you is trying to give its energy to the cold that's in the cup. So that goes from a gas to a liquid. It loses its energy, so it liquefies on the side. I believe that's how it is. I could be wrong, but I'm pretty sure I'm right. And then from a liquid to a gas, it's called vaporization. Again, it happens at the same degree of a given substance. Just depends on whether you're losing or gaining energy. And there's one more. You can go directly from a solid to a gas. It's called sublimation. And that example is dry ice. Right? If you've never seen dry ice, it's a cool experiment to do. You have dry ice, it goes from solid to gas. All right, now with some closing stuff. If a substance is melted from solid to liquid, the density, energy, and intermolecular bonds are all affected. So when you go from a solid to a liquid, the bond between it is affected because the bond becomes weaker. The energy is because you are gaining energy, and the density is also affected of the object. Alright, if the amount of intermolecular bonds of a substance are changed, then the volume and density change also. So density is just mass over volume. So as you increase the heat, you lower the density. So this has high density, lower density, lowest density. So high, medium, low, if you want to think of it that way in terms of density. Alright, this has been me stumbling my way through states of matter. Hope it helped. Good luck.